Hi, my name is Casey Grotov, and I'm going to be talking about my final project, Rack and Repeat. So, the idea between Rack and Repeat is that, first of all, I'm really, really into pool right now. I play a lot of pool at bars and also just for fun. I got myself a cue stick, and so I'm really interested in getting better. And one of the things that professionals do to get really, really good is they hit the same shot a million times. And so when it comes up in a game, they know without a doubt that they can make that type of shot. And so one of the things that you have to do is place the balls obviously in the same spot every time. And without having like a sticker or something for where you need to put the balls, which I'm not allowed to do because I'm playing on like tabletop and not mine, um, it's really difficult to like put it right in the right spot every time. And so it also just takes a minute. And so what I wanted to do was make something that sets the ball there perfectly each time without even having to worry about it. I've seen other competitors like do it, but what they do is instead it's kind of like, you know how golf balls get put down on their tees? It just like puts it in the same spot every time. And what I wanted to do was make it to where I could tell an angle and then I could do a bunch of different practices all in one like go. So this is the system overview. This is the CAD for it. Those two brown pieces are wood pieces that I've cut out for myself at the Build Lab, and then everything else that's blue was 3D printed. The hopper took a lot of different parts because it's a massive piece. My idea was I wanted it to be able to hold all of the balls in an entire rack, and so I wouldn't have to reset very often. The main components of the system, the actuators are the ramp gate, which is a servo, the hopper gate, which is also a servo, and then the ramp pan angle. So this entire ramp stays static. In my next iteration of this, I want to have the ramp be higher and lower so I can actually put it wherever I want on the table. But for this version, um, there's a turntable at the bottom there, and underneath and printed into the base is a pulley that I catted up. And so there's a timing belt that's connected to the pan angle stepper motor. For the sensor, I have a ball detector, which is using my ultrasonic sensor. It just detects if there's balls in the hopper already, and it'll tell you on your phone if you're missing the balls or not. And then lastly, there's an OLED screen. The OLED screen kind of just displays like information, like this preliminary information. It tells it the status and if it's ready or not based on if there's balls there. It talks about how many balls have been placed and also the angle that the balls are at. I mean, the angle that the ramp will be set to. And also at the beginning, since I decided to use a Wi-Fi connection, it tells you the IP address for the website. So as for this is just like what the physical system actually looks like. Like I said, I cut the plywood out at the Build Lab um, and then screwed through it a million times for different ways to mount to it. And then this is the ultrasonic hopper gate and the ultrasonic and the hopper gate, and then also the ramp gate. All pretty simple stuff. Um, Next is the way that I connect. So what I did was I did a Wi-Fi website. I saw a couple different ways to do this, and then I had Claude make the website itself because I don't know HTML super well. And so that pan angle is a slider that goes from -115 to 10 degrees because obviously you can't go into the wall, and so you don't need to go any more than 10 degrees and -115. So it also tells you if there's no balls in the hopper, and how many balls are placed. And then when you press that release button, the sequence will start. Like I said, the OLED displays the IP address for the user so they can enter it into the browser and then be on the same internet with the Arduino. So the way that the system works is, like I said, the user moves the slider to the desired angle. They press the release button, and then the hopper gate dispenses the ball onto the ramp. The ramp turntable positions to a desired angle, and then the ramp gate releases the ball. And then it returns back to home and starts the whole process over again. So here's my demonstration of that. So right now it's going to about 25 degrees. I was having issues with my stepper motor being accurate to its angles. In FutureWorks, I really wanted to use a NEMA 17 stepper motor, and I bought motor drivers for them, but I was having issues with just connections where it was not like the connections weren't good enough, and so the stepper was moving really finicky. And so this is another one. It's a little bit further than the first demonstration. Again, in FutureWorks, I'd like for the stepper angle to be extremely accurate. And like I said, it'll be using a NEMA 17, just like the ramp adjust, which I will do in the future. So these are just pictures of the different mechanisms. The gate, the cool part about the hopper gate is that you'll see it in this bottom right picture, but it'll open to let the next ball in and then stop the ball before it. And then it lets the ball in, it lets the next ball in and then close it around it. And so that's how I ensure that only one ball gets released into the ramp at a time. Um, that top bottom right picture is before I made the improvement of having it attached on both sides. Then the ramp pan angle stepper. What's cool is 3D printed into the base itself. There's a pulley outline, and so I'm actually using a timing belt around the 3D printed part and the stepper motor, and then I have a belt tensioner there that's like the spacer, and I'm using a thrust bearing that's actually sandwiched in between the turntable and the ramp, and so it's actually super frictionless, which is awesome. And then the ramp gate is pretty simple. It's just a servo. As for the circuit, pretty simple stuff. It's once it was all working is quite simple. The I used a battery pack because I wanted this thing to be able to work without being connected to a wall because obviously pool tables are kind of in the middle of a room, and so it's connected to my Caterpillar portable charger that I got for my internship. And that powers the Arduino, and then I have a 9-volt battery that powers the stepper driver. And then I had a 12-volt like battery, but I didn't get to use it because my stepper drivers weren't working for the NEMA 17s. And then these are just the connection points. The stepper driver, the hopper servo, and the ramp servo are all connected to the Arduino, and so is the ultrasonic and the OLED. And those are the pins that I'm using. And that is my full project. And here are my references. So thank you.